Hello friends, till now we have studied about electrostatics under electromagnetism. Electrostatics under electromagnetism. The science in which we have studied about the charge in rest. Charge in rest. Now we will talk about electrodynamics, in which we will talk about the charge in motion. We know in a free fall, a body always moves from a higher gravitational potential to a lower gravitational potential. For example, I have water in one vessel, so if I will start dropping it, I will have to bring it at higher level. So charge will move from higher potential to lower potential. See, higher potential to lower potential. But this lower water will not go up. Okay? In the same way, when we connect two vessels, so I have two vessels. Two vessels containing water up to different level are joined together near the base. So water will flow from the vessel containing water at higher level to vessel containing water at lower level. So water will flow from higher level to lower level due to difference in hydrostatic pressure. Hydrostatic pressure. Due to difference in this hydrostatic pressure, water flows from a higher potential to the lower potential. This flow of water continues till both the vessels have water at the same level. The direction of flow of water does not depend upon the amount of water in the vessel, but it depends only on the height of the level of water in the vessel. Similarly, if two charged conductors are joined by a metallic wire, suppose I have charged conductor, two charged conductor, and they are joined by a metallic wire. They are charged conductor, and when these two conductor are joined by a metallic wire, the direction of flow of electrons is determined by the quantity called electric potential. That is called electric potential. Actually, this electric potential determines the direction of flow of electron. In the previous lecture, we have studied about electric potential. What is electric potential? We have studied in electrostatics in the previous topic. The amount of water to bring unit positive charge from infinite to a certain point within an electric field is called electric potential. So, electric potential V equal to W by Q, or potential difference V1 minus V2 is equal to W by Q. So, what is a potential? Actually, potential is the electric state of a conductor, which determines the direction of flow of charge when the two conductors are kept in contact or they are joined by a metallic wire. So, potential is what is electric potential, or in other words we can say potential is the electric state of a conductor, which determines the direction of flow of charge or electron when they are connected or kept in contact or joined by a metallic wire. The magnitude of electric potential is measured in terms of work done in moving a test charge. This movement of charge is called electric current. So, what is electric current? So, electric current is the rate of flow of charge through any cross section of wire. Okay. So, I am writing it. So, electric current the rate of flow of charge through a given cross section of a wire is called an electric current. Okay. So, the rate of flow of charge through any cross section of wire is called electric current flowing through that conductor. Suppose a conductor, and this is a cross section. So, at any instance, total amount of charge is passing through this conductor is Q. So, at time t, so current I will be equal to Q by charge, that is rate of flow of charge. Okay, that is rate of flow of charge, and this electric current is measured in ampere, and it is denoted by capital A. So, unit of current is ampere. You might have observed, when water flowing into a river, we call it current of water. In the same way, when electrons or charge flowing through a conductor, that is, we call it electric current. Okay, when water flowing through a river, we call it current of water. In the same way, we call electric current when electron or charge flowing through a conductor. Actually, we take the direction of current opposite to the direction of flow of electron. The electric current has magnitude as well as direction, although it is a scalar quantity. It has direction and it has magnitude, but it is a scalar quantity. Why? Because we do simple algebraic calculation with current. For example, 2 ampere of current coming from this direction, and suppose 3 ampere of current from this direction. So total will be 5 ampere, the algebraic sum of these two. So this, in this conductor, total electric current will be 5 ampere. So we do algebraic sum. So electric current do not follow any vector addition or triangle law or any parallelogram law. So electric current doesn't follow any vector law or vector addition or triangle law. Okay. So the conventional direction of electric current is the direction of motion of positive charge. Okay. The question arises, why is the direction of flow of electron opposite to the direction of flow of current? Actually, why? Current electricity was discovered in 18th century. It was known that there was two types of charges, that is positive charge and negative charge. It was known, but electron was not discovered at that time. So electric current was considered to be a flow of positive charge. That time it was considered, and the direction of flow of charge was taken to be the direction of electric current. Thus, the conventional direction of electric current is from positive terminal to the negative terminal of a cell throughout the circuit. So, in our circuit diagram, we put an arrow on the wire. How? We draw a wire and put an arrow. So, in our circuit diagram, we put an arrow like this, pointing from positive terminal to show the direction of conventional current. The actual flow of electrons is, however, from negative terminal to positive terminal, positive terminal of a cell, which is opposite to the direction of conventional current. Unfortunately, when electron was discovered, people suddenly realized that the earlier arbitrary choice has been wrong. But it was too late. It means that all the mathematics, our electric fields, notationally point from positive to negative to change also. That will have to change also. So positive to negative will have to change, and also we have to train accordingly, which is not possible. So finally, the conclusion. What is we discussed? We discussed electric current. So electric current is flow of electron, but the flow of electron is taken to be the direction of opposite to the electric current. Okay. So the rate of flow of electron is electric current, or the rate of flow of electric charge is electric current. But when we talked about electrons, the flow of electron and the direction of current is taken opposite to each other. Okay, and so I equal to q by time, charge following per unit time. So rate of flow of charge is called electric current, and unit of current is ampere. And an instrument by which we measure electric current, that is ammeter, and the symbol of ammeter is a circle, and in between A is written, so it is the symbol of A. And this ammeter is connected in a circuit in series, not in parallel. Mind it. Always connect an ammeter in a circuit in series to measure current. Okay. Now, also we talked that electric current is a scalar quantity. Why it is a scalar quantity? As it is having direction as well as magnitude, but it is a scalar quantity, not a vector quantity, because it do not follow a vector addition. Okay. Now, what is a vector quantity? What vector quantity is the physical quantity which have magnitude as well as direction, and it can be added through a triangle law. This electric current do not follow triangle law. That's why electric current is a scalar quantity. According to the magnitude and direction, electric current is of two types, that is DC and AC. You might be knowing. DC means direct current. So the current in which the direction is fixed is called a direct current. So there is two types of current, that is direct current and alternating current, AC. One is DC, that means the electric current in which magnitude and direction is always fixed. So there are two types of current, that is direct current, and another one is alternating current, that is AC. In DC, the electric current in which the magnitude of and the direction always fixed. Okay. So what are the sources of direct current? The sources of direct current are the cell or the battery or the DC dynamo. Okay, these are the sources of DC direct current. And AC means alternating current. Alternating current are those in which the direction and as well as magnitude always changing. The electric current in which the magnitude as and direction is not fixed. Okay, so in alternating current the direction is keep on changing, and in the DC the magnitude and direction is not changing. That means the current in which the direction is fixed, it means the magnitude and direction do not change with time. And the sources of direct current is a battery or a cell and a DC dynamo. These are the sources of direct current. AC means alternating current. The current in which the direction keeps on changing. Sometimes it's positive to negative terminal and sometimes negative to positive terminal. Okay, I mean to say that an electric current whose magnitude changes continuously and changes the direction periodically, time to time it changes, that is called alternating current. And the sources are AC dynamo. Of course, the AC dynamo is the source of alternating current. DC is indicated by DC. So direct current is indicated by capital I. Okay, and alternating current for AC we use small I. So for alternating current. Okay, the amount of current passing through per unit area of a conductor is called current density. Suppose a conductor, I am omitting it. Suppose a conductor and the cross section area is A. So amount of current suppose passing at an instance is I, then current density J, actually current density is indicated by capital J. So current density J is equal to I by A. So the amount of current passing through the per unit cross section area of that conductor is called current density. The electric current following per unit area of a cross section of a conductor is called current density. It is denoted by capital J, and the current density J is equal to I by A. So the unit, what will be the unit? So I ampere and A, that is meter square. This is the A is area. So the unit will be ampere meter. Ampere meter square or ampere per meter square. Ampere per meter square or ampere meter square. The current density is a vector quantity. The direction is in the direction of motion of positive charge or in the direction of the flow of current. The free electron in a metal move randomly with a very high speed of the order of 10 to the power 5 meter per second. 10 to the power 5 meter per second. This speed is called thermal velocity of a free electron. So thermal velocity is what? The free electron in a metal moves randomly with a very high speed. What is speed? At almost 10 to the power 5 meter per second. So this speed is called thermal velocity. the speed because of thermal effect, because of the heat. Okay, so the speed of electron is 10 to the power 5 meter per second in a metal. So average thermal velocity of free electron in any metal is the direction remains same. The average thermal velocity of free electron in a metal in any direction remains 0. Okay. Now we'll talk about drift velocity. Drift velocity of a free electron is, when we let us see, we'll have to omit it. Now we'll talk about drift velocity. And this is indicated by Vd. Okay. So when the potential difference is applied across a conductor, suppose this is a conductor, and the potential difference V is applied through this. So when the when the potential difference is applied across a conductor, across the end of the conductor, okay, so the free electron in it moves with the average velocity opposite to the direction of electric field. That is called drift velocity. What I said, when we apply electric potential in between two terminals of a conductor, so what happens? The free electron moves with the average velocity opposite to the direction of electric field. So opposite to the direction of electric field, that is called drift velocity. Okay. So drift velocity is indicated by Vd, and it is given by Vd. Vd is equal to E, capital E, T by M. Okay. Where E is the charge on electron. E is charge on electron, and E is, capital E is electric field intensity, that is strength of the electric field, and T is the
relaxation
and
time.
M is mass of electron. Okay, so the drift velocity is indicated by small e, the charge on electron, the electric field intensity, that means strength of the electric field, and the relaxation time of the electron. Okay, and sometimes we indicate Vt, that is equal to EVT by ml. EVT by ml, where E is the same thing, charge on electron, V is the potential difference across the conductor, and T is the relaxation time of electron, M is mass of the electron, and L is the length of the conductor. If length of conductor is suppose L, electric field intensity at some time it is E, and electron having charge E, then so drift velocity will be either, if you know electric field intensity, so you can calculate it by Vt, electric drift velocity, charge on electron multiplied by electric field intensity and relaxation time, that is divided by mass. Or if you are knowing potential difference, then E, that is charge on electron, the multiplied by potential difference multiplied by relaxation time divided by mass of electron, and then divided by the length of the conductor. Okay. Now next topic is mobility. It's very small. We'll have to know the definition only. So what is mobility? First we'll have to erase it. What is mobility? mobility. And this mobility is indicated by mu. The drift velocity of electron per unit electric field intensity, that is electric mobility. Okay, so suppose mu will be given as drift velocity electric field. So what is my mobility? The electric field intensity mobility, drift velocity per unit electric field intensity. Okay, or the strength of the electric field. So what is mobility? Mobility is the drift velocity of electron per unit electric field intensity. Okay, and so if mobility is mu, then mu will be equal to drift velocity divided by strength of the electric field. So the unit will be meter square per second per volt. So unit of mobility is meter square per second per volt. Okay, so we talked about electric current. So finally, what is electric current? Electric current is the rate of flow of charge. We consider it a flow of rate of flow of electron also, but the direction of electron and the direction of current is taken as opposite. We can also define as the rate of flow of positive charge. Okay, and the unit of electric current is ampere, indicated by A, and we measure this electric current with the help of our instrument that is called ammeter, and ammeter is connected in series. Okay, and what else we talked? We talked about the drift velocity, the mobility. Okay, I hope it will help you. Now next day we will discuss more about electric current and will proceed further. We will talk about the resistance, the resistivity, and the Ohm's law, and also combination of resistance. A lot of things we have to discuss. Today was a very descriptive lecture. I hope you understood. So thank you very much.